This video tutorial is for pages 6 and 7 in the acid-base homework. So I thought I would go through a few of the problems. The ones that I'm doing are highlighted. Number 1 says, what does it mean when the formula of a particular ion or molecule is enclosed in brackets? And these are brackets. They're square brackets. For example, NaOH in these brackets means concentration. That's what these brackets mean, is concentration. Concentration of sodium hydroxide in this case, because whatever's in the brackets, that's what you're looking for, the concentration of. Number 5, given the H plus value is 1.0 times 10 to the negative 6 molar, what's the pH? Well, remember that we learned if you take the exponent and you make it a positive number, that will equal your pH. So in this case, the pH is 6, and acids have a pH lower than 7, bases have a pH above 7. So a pH of 6 would make this an acid. Number 7, a solution has a hydrogen ion concentration of 1.0 times 10 to the negative 9th molar. Well, there's our little exponent. We're going to make it positive, giving us a pH of 9. So remember, if the pH is greater than 7, it will be a base this time. Okay, pretty easy. Look at that exponent. Number 12, which of the following is the strongest acid? All right, so acids and bases, I'll just put the pH scale here, 0 to 14. This is neutral. 7 to 14 is a base. Between 7 and 0, acid. The closer you get to the end number, the stronger the acid or base. If it's close to 7, that's a weaker acid or base. So what I'm looking here, when I'm looking at the strongest acid, I look at the number, the exponent. A would have a pH of 4. B would have a pH of 11. C would have a pH of, 1. And D tells you the pH is 12. Well, the strongest acid would be the one that's in this range, 0 to 7, but closest to 0. So the correct answer is C, has a pH of 1. Number 13 is asking about which one has the strongest base. Well, we're going to do the same thing. We're going to look at the exponent, make it positive, so the pH would equal 4. Here, pH is 1. That's really a strong acid. pH of 12, wow, that's probably it, but let's look at this one. This one has a pH of 9. So the number that's between 7 and 14, but closest to 14, will be my strongest base, which will be this number right there. Okay, page 7. More of the same, guys. More of the same. The H plus ion concentration is 1 times 10 to the negative 7th. So that means the pH is 7. So what do you think that is? Well, we did the pH scale here. I'll do it right there for you. 0, 7, 14. And I told you that 7 is what? That's neutral. So our solution with a pH of 7, neutral. Okay, on the bottom, let me do some of these. It's been a while since some of you guys have had to name and write formulas. So let's see if we can't get through this. ZnOH2. Okay, Zn is the symbol for zinc. And OH is a polyatomic ion. Oop, I was going to get you the polyatomic ion sheet. OH is hydroxide right there. Okay, so when you see the OH, you'll write hydroxide. Bases will end with a hydroxide on the end. That would be a base. Acids generally begin with a hydrogen at the beginning. So OH at the end for a base. H at the beginning for an acid. So zinc hydroxide would be a base. Sulfurous acid. Okay, so each teacher taught a different trick to remember how to change the end of the polyatomic ion when you're naming acids, oxyacids specifically. So sulfurous acid, what I taught my kids is I ate something icky. So polyatomic ions that ended in ATE get changed to ick. I also taught them that a snake bite is venomous. If it ends in ITE, the ending gets changed to OUS. Well, in this case, we already have the OUS, so the polyatomic ion must have come from something that ended in ITE. Well, this gives us a little bit of a clue. Sorry about that bell. This gives us a clue. So if it ended in ITE and the beginning is sulfur, let's see what that could be. Sulfite ends in ITE. So the polyatomic ion for sulfurous acid is sulfite. Since it's an acid, we give it a hydrogen. Then we write the formula for sulfite, which is SO3. Check oxidation numbers. Hydrogen's oxidation number is +1. Sulfite, -2. Crisscross those oxidation numbers. Use them as subscripts. And you can erase. You don't need them up there anymore. So the formula for sulfurous acid, H2SO3. Is it an acid or a base? I don't know. That gives us a big clue. It's an acid. Those are pretty easy. Okay, here's another one down here. But the problem with this one is not the same as this. They're both acids, but look, this one starts with the prefix hydro. If it starts with the prefix hydro, that means it's a binary acid. Binary acid means that there are only 2 elements in the formula, one of which has to be hydrogen. So to write the formula for hydronitric acid, I'll start by writing a hydrogen. And then nitric came from just plain old nitrogen. Okay, change the ending to IC and add acid. So H and an N, binary, 2 elements. The oxidation number for hydrogen, +1. Nitrogen, -3. That's +1. Crisscross those, use them as subscripts. The formula for hydronitric acid is H3N, and I can erase the the oxidation number, that I'd written at the top. So again, this one's an easy one. It's called hydronitric acid, so it must be an acid. Okay, aluminum hydroxide. Well, there's my hydroxide again that we talked about up here. So if it says hydroxide, it's a base. This one, we just get to write the formula the way that we learned how to write the formulas during the ionic compounds unit. I write the symbol for aluminum. Aluminum is Al. I write the symbol for hydroxide, same as this. It's OH. Then I write oxidation numbers above them. Aluminum has an oxidation number of +3. Hydroxide has an oxidation number of -1. Crisscross and use them as subscripts. So the 3 goes out right here on the outside of those parentheses. And there's an understood 1 next to aluminum. And I can erase those oxidation numbers above it. So the correct formula for aluminum hydroxide, AlOH3. I hope this was helpful, and ask your teacher if you need extra help.